Hey guys, welcome to my talk on building efficient RAG applications using frameworks such as LangChain and LlamaIndex. So my name is Pawan Belagati and I work as a technology evangelist at Single Store. Single Store is a relational database company and you can also use Single Store as a vector database to build robust RAG and AI applications. So let's get started with building efficient RAG applications. So this is my table of contents, building AI applications, how complex the journey is all about, and we will talk about LLMs. I'll talk about chatbots, LangChain, different components of LangChain. We also call them modules, and we will also talk about the other framework that is LangChain and I'll also talk about RAG with retrieval augmented generation with LangChain and retrieval augmented generation with the LlamaIndex. I'm going to show both the tutorials or demo using LangChain and LlamaIndex at the end. So let's get started. So building AI applications, right, without the frameworks that we saw, right, the LangChain and the Llama Index. So building AI applications is kind of scary actually without these AI frameworks. It's kind of because it is scary because it has multiple process involved in it, and it is kind of complex. And we also see that there is a skills gap in the industry because AI is moving so fast, right? It all like building a robust AI application can start with data collection, data processing, data cleaning, model training, hyperparameter tuning. All these things add up an extra layer of challenges to the folks who are building this, like for developers. And and like I said, it's kind of a lot. There's a lot of effort required, and it's a very complex process at each stage. And there requires a lot of skill set where it's kind of lacking in the industry because because the pace that AI is moving so fast. So the whole idea of this slide is to make sure, to let you know that building AI applications is not that easy without the AI frameworks. So you might say, hey, Pawan, LLMs are just enough. But what exactly LLMs are made up of? They are made up of some kind of data and the architecture, like the transformer architecture and some kind of training. So that's how LLMs are made up of. And they are just a piece of the puzzle, like for building robust AI applications. So you need something more than LLMs, right? Like I said, LLMs are just one piece of the puzzle, right? Who will take care of the data management, data ingestion part, data processing, vector storage integration, infrastructure management, integration, business logic integration, application logic. Now, all these things are actually required to build robust AI applications, which LLMs using just LLMs, they won't provide you that, right? But you might say there are already chatbots using LLMs, but you know, there are chatbots using LLMs, but all they do is, what do you call, like just like your Alexa or Siri, everything is pre-fed. They don't generate anything new, right? It's just they can't you can't build a custom chatbot application using just LLMs, right? And this whole thing lacks a connected knowledge. What if you're working in a healthcare sector? The chatbot doesn't understand your LLM that you use, doesn't understand the language that you use, some of the words that you use in your healthcare. So that's where the chatbots just using LLMs fail. So that's where you need to have more integrations, and that's why effective AI applications require comprehensive AI frameworks and some kind of integrations just beyond LLMs to ensure robust performance and reliability, right? So, what are the critical limitations that chatbots using LLMs will have, right? The first thing is like they are restricted to their training cutoff date because LLMs have a cutoff date, training cutoff date. So they are restricted chatbots to their own data. They can't retrieve the real-time information and they cannot even verify the accuracy of their responses, right? How will you know the chatbot is generating the proper answers, right? And they can't integrate with business systems or logic, right? Application logic. They can't reason. They can't do reasoning and all those things. So that's where chatbots just using LLMs fail. So Now we saw that LLMs are not just now. So what exactly do we require? We require LLM frameworks, or you can call them AI frameworks like LlamaIndex and LangChain. So we'll talk about them one by one. LangChain is kind of is an open source platform to help you build LLM powered applications. Just understand that it's very simple, and it's developed by Harrison Chase, and it came out in 20 October 2022. And LangChain basically streamlines the intermediate steps that we saw in the chatbot creation, right? And AI applications to so that you can develop very data intensive applications. So, what exactly is the literal meaning of LangChain? Lang comes from the language models, right? The models you see now, Chat, GPT-4, Claude, Llama, Mistral, Palm, DeepSeek, and all these things. And chain refers to the concept of chaining together different components into workflows. So you can basically make use of LangChain components or modules, what we call, and you can chain them together to basically build complex workflows so that you can automate your tasks, right? The way, as you can see, the right hand side chain, the workflow components you can, I mean, input, process, and output. So these are the main components of LangChain. LLMs, it's LLM agnostic. You can use open source or closed source LLMs. And indexes, it has document loaders. You can load documents, text, there are text filters, vector store integration and retrievers and agents. And you can also leverage LLMs for reasoning to automate decision making and all those things. Basically agentic applications you can create, and there is a memory you can have, long term, short term memory, and all those things. And chains, the main concept of LangChain, the chains. You can combine LLMs with modules to execute a sequence of functions and to basically build autonomous agents and workflows. And there's also prompt templates, reusable and customizable templates so that you don't have to create your prompts again and again. You can reuse them. For example, you want to build an application where it is for kids, and you want the application to respond everything as if it's responding to an 8-year-old kid. So that's how you can basically create that whole application so that it always generates such type of responses back to the user. So these are some of the components of LangChain, and that all these things give power to LangChain to help you build robust AI applications. And this is how LangChain is growing on Google because, I mean, that's how people are searching basically. So many people, obviously, because LangChain has the first mover advantage in the AI space as an AI framework, LLM framework. So I went ahead and searched about it in Google Trends, this keyword LangChain, and this is how it is growing up and about. So everybody wants to learn LangChain and want to build LLM powered applications. And this is on GitHub, how they are growing, the GitHub stars, right? It's also growing up and above. So there is a lot more going on with LangChain, and the growth is phenomenal. And this is kind of a simple LangChain timeline, how they started, how did they get, how when they did the first PR, the first tweet by Harrison Chase, as you can see um on the screen. He just tweeted introducing LangChain, a Python package aimed at helping build LLM applications through composability, and pip install LangChain. And on Jan 8th, somebody shared this on Hacker News, which went kind of viral. And excuse me. And Feb 9th, they did their first meetup, and Feb 20th, they received 10K stars on GitHub, and April 4th, 10 million benchmark, 200 million valuation on April 13th, and July 28th, Langsmith, the first managed services came out, and October 2nd, 2023, 63.4K stars and got some enterprise class clients. So the if anybody is into AI startups, it's a very good case study for them to learn how LangChain did it so well. So this is a little bit about LangChain on Udemy, the learning platform that we all know. So this is how, Udemy recently did a 2025 Global Learning and Skills Trends report, which basically highlights how LangChain is growing. As you can see, almost 4,000% increase right? The top 10 surging technical skills. That's amazing. I mean, and again, same thing, top 10 consumed skills. One of them in AI is LangChain, almost the third one. So as you can see, LangChain, everybody wants to learn LangChain and understand and want to build LLM powered applications using LangChain. And why exactly people use LangChain? What are the principles of LangChain, right? So, for example, if you are building custom applications with your own data, right? Access the that data to have the access to that data, such as enterprise or developer owned data, various other data, right? That is private and all that. So, this data awareness is the first principle by LangChain, right? So that you can build your own customized applications with your own custom data. And then the second principle is it can basically help you interact with other tools, APIs, tool calling, API calling, all these things, uh, Python compilers, math calculators to basically realize various rich product functions so that you can build all those product functions. So this agentic behavior is the second principle of LangChain. So these are some of the use cases of LangChain. As you can see, these are the modules, LLM, memory, prompts, and agents. So with all these things chaining together, you can basically build question answering over docs, text summarization, chatbots, querying tabular data, interact with APIs, and code understanding. So can basically build all these things. And getting started with LangChain is kind of very easy. I'm more of a Python guy, so I use pip install LangChain. And if you want to use third-party integrations, you can install pip install LangChain community. And if you want to use different models, LLM large language models, they're like you can go with LangChain OpenAI, LangChain Anthropic. So depending on the type of LLM you want to use. So LLM application development with and without LangChain or something like LlamaIndex, right? So as you can see, without such a platform like LangChain, it would be very difficult for your developers to build, hard code everything. They have to do custom API authentication, rate limiting logic, custom prompt templates, vector DB integration. They have to figure out a lot of things. But with LangChain, as a as an all-in-one framework, it gives you everything like built-in authentication handling, integrated rate limiting, prompt templates, vector DB integration, document loaders, memory components. So it simplifies your whole application, AI application development. So that's it about the LangChain part. And let's move on to the LlamaIndex, which is the another open source platform to help you build LLM powered applications. So LlamaIndex is a data platform that helps developers create applications using LLMs. So as simple as that. Like we saw, right, the basic chatbot using LLM will have a lot of limitations like no access to current information, cannot verify their own responses, no connection to the external data. That's how the chatbot can hallucinate more, come up with its own fake responses and made up responses and all that, limited to training data cutoff and no business logic integration and all that. So these are some of the limitations as we saw previously also. So all these things are can be, bridged using LlamaIndex. So LlamaIndex connects the LLM to external data sources so that you can get real-time data and proper contextually relevant responses to the user query. And it indexes data so that it can be efficiently searched and retrieved properly rather than relying on the LLMs. And it verifies and cross-references content, boosting the accuracy of responses. And also it integrates business logic, application logic, and domain knowledge so that responses adhere to specific organization rules. So Llama Index here comes as a savior to uh, mitigate all these what do you call limitations of the chatbot just using LLMs. So what exactly is the literal meaning of llama index? Llama means this kind of an animal, as we all know, like often associated with carrying loads of large loads, symbolizing, the ability to store and access large amounts of data. with indexing as a part, which refers to the structured way of organizing data for efficient retrieval, right? This will basically help in your RAG applications while you're building RAG applications. So once you when you go to Llama Index website, you will find two things. One is Llama Cloud and the Llama Index. What exactly is Llama Cloud? Llama Cloud basically, as you can see, it connects with different various data sources. It can be like your Notion, uh, docs, PDF files, single store, Slack, uh, Salesforce data, and all these things, which all this data can be indexed at as a centralized, a place called index, and that helps you basically ingest and sync data sources easily, build and maintain indexes. So Llama Cloud does building and maintaining of the index, whereas Llama Index is the open source part that will help you. It serves as an orchestration layer, whereas layer that processes the indexed data and helps you build capabilities such as, like, search functionalities, chatbot applications, and agentic workflows, and all these things. So they're basically two parts: Llama Cloud, which basically indexes data from different data sources, and Llama Index is the orchestration layer. That's where you can build, that comes up with the capability that helps you with building search functionalities, chatbots, and agentic workflows. So yeah. So this is the growth of Llama Index, like how we saw for LangChain on Google Trends. If you go to Google Trends and search for this keyword Llama Index, this is how it is growing up and above. Just like LangChain, Llama Index is growing really well because Llama Index has really good integrations and it's very smooth and very easy to use. And this is again the growth of Llama Index on GitHub with a GitHub star history. This is also growing up and above, and yeah, this is a simple Llama Index workflow where, as you can see, your documents get loaded. The Llama Index provides different components at different stages. Like load, it has uh, like loaders, and your documents gets loaded and then gets parsed, and they get indexed, and all the documents after indexing get stored in a vector database, vector store. And for any user query, the query goes through the vector store to find the relevant chunk, and and finally it goes through the LLM model to answer back to the user. So as you can see, at different stages of the whole pipeline, Llama Index gives different tools for you. Yeah. So let's move on. Uh, if you guys are building the Gen AI applications, so this is a simple Gen AI dev stack that has different layers, like 5 layers: UI layer, service or chain layer, model layer, storage layer, and the infrastructure layer. So the whole point of this slide is to show where exactly the LangChain and Llama Index come into play in the whole Gen AI dev stack when you're building Gen AI applications. So they basically come under service or chain layer to help you build robust AI applications. And this is about the RAG, Retrieval Augmented Generation. Since the demo or the tutorials that I'm going to show is all about RAG, building RAG applications using LangChain and Llama Index. Let's understand what is RAG a little bit, right? So what happens basically, LLMs, large language models, hallucinate. For any query, sometimes they can come up with their own answers, made up answers, which is not correct, like fake answers, and all these things. So this behavior of LLMs is known as hallucinating behavior. When they make up their own answers and kind of come up with their own, made up or not correct answers. So to mitigate this LLM hallucinating behavior, we basically have um, three important techniques. One is fine tuning, prompt engineering, and the third one is RAG that we are talking now. So RAG is an approach that gives LLMs the context about your data, where you basically um, through an external database, you feed in the proper data so that the LLM can easily go fetch the proper data without hallucinating, right? So this data can be augmented using an external database, like what we call vector database, right? So RAG connects your AI applications and systems with external knowledge sources so that accurate and contextually relevant responses can be retrieved or generated. As you can see in the image, right? It all starts with document processing your documents, right? The whole document gets chunked, and every chunk is assigned with a numerical number, and that's how vector embeddings are created. And all these vector embeddings are stored in a vector store, or what you call vector database. And then comes the query processing, where user query comes in, and even the query gets converted into an vector embedding, and then it goes through the vector store through vector similarity search to find the relevant chunk. Now you have augmented query a relevant chunk. It goes through at the end to an LLM, large language model, to generate a proper contextually relevant answer or accurate answer back to the user. So this is the whole RAG pipeline setup. And let's take, for example, right, a RAG application example. If you're working in a healthcare sector as an assistant or a researcher, if you ask a query to your application that's only using pre-trained LLMs, right? Hope you know that all these pre-trained LLMs will have a knowledge cutoff date, right? And they can't access the real-time data. So if you ask a query like, what treatment options for this patient with stage 2 NS, CLC, blah, 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 the your application will come back and answer saying, it will respond back saying, based on my training, standard options include surgery, chemotherapy, or radiation therapy. That is without RAG, right? Since your whole system doesn't have any context and there is no additional info, it is only based on the pre-trained LLM's response. Now you give additional info like latest clinical guidelines, recent trial results, and patient-specific factors. That is where with RAG, you provide all this information through an external database or a vector store, what you call. So for the same query, if you ask the same query, like what treatment options for this patient with stage 2 NSCLC, now the answer is more contextually relevant, like based on 2025 NCCN guidelines and recent trial keynote, blah, 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 immunotherapy with dash, dash, blah, blah, blah is what the good response is all about, right? So that's how you can basically make use of RAG in your applications while you're building robust AI applications. And yeah, I mean, LangChain provides different tools, libraries at the different stages of the whole RAG pipeline. As you can see here, right? When you for loading your PDF files, there are document loaders, there are text splitters, there are it gives you LLM models, and it has good integration with vector stores, vector databases. So as you can see, at different stages of whole RAG pipeline, LangChain has necessary tools through its modules that it provides, and so that you can build a robust RAG or AI applications. And then similarly, LlamaIndex in RAG pipeline, LlamaIndex simplifies the building of RAG application or RAG pipeline by providing different tools for ingestion, data ingestion, indexing, and querying data to augment LLMs with the context specific knowledge, enabling more accurate and relevant responses. So at each stage, Llama Index also has different tools that it provides so that you can build, um, you know, uh, contextually relevant RAG applications, right? At different stages, as you can see here. And yeah, let's talk about typical enterprise data architecture, right? As you can see here, right? At a certain point in your company, you feel like having OLEP database because most of your customers are running analytical workloads. And then at certain point, you feel like, most of your customers will ask for it, like a feature, like to support, they are running transactional workloads. And then you feel like having a transactional OLTP database. And then now the hype is all about Gen AI applications, and you feel like having a vector database. And if you see the whole setup here, it's kind of very complex and very confusing for any data architect in your company or an AI architect to suddenly grasp everything, because it creates a lot of complexity while building, AI applications, because you're using a lot of different databases at different stages for two different things. So here, single store can come in as an all-in-one database to help you build robust AI applications. It will help you with, ingest and index documents, re-ranking, hybrid search, filtering, similarity matching. Basically, single store started supporting vector storage long back in 2017 itself. So you can use single store as an all-in-one database and basically remove all the other databases. So yeah, I mean, this is how we usually say on our website. If you go to singlestore.com, it says like the only database you will ever need. You can scale from 1 to 1 million customers, handling SQL, JSON, full text, and vector workloads all in one unified platform. So single store supports OLAP, OLTP workloads, and it supports all types of data, as you can see here, right? JSON, full text, vector data, and all those things. And single store also has a free share tier where you can just sign up and start using the free share tier until you finish off your credits. And these are some of the global leaders that choose a single store for their everyday workloads: LG, Nvidia, Hulu, Heap, Adobe, um, Dell, and all these guys, Samsung. So this is my RAG with single store setup. This is what I'm gonna show in the tutorial today. So using LangChain as my framework, we have a PDF. I have a PDF file that I'm going to chunk and create embeddings, and all these embeddings are going to be stored in a vector store like single store database. And then for any user query, the query also gets converted into a vector embedding. It goes through the vector store to find the uh, matching document, and at the end finally it goes through the LLM model to answer back to the user. So this is the whole setup. I have a notebook I'm going to show you. So let's go to the so for this, you need to have a single store cloud account. It is free to create. Go to singlestore.com and sign up, or you can take a screenshot of this and then go there. And you need to have OpenAI API key, because I'm going to use OpenAI to create vector embeddings. And then the first thing is to create a workspace and a database to store our vector embeddings. And then next is to create a notebook. Single store has a feature where you can create notebooks just like your Google Colab, and make sure to select workspace and database on your notebook. So let's see how we can do that. So I have the OpenAI API key ready, and let's go to single store. We need to have single store account. So I already have the account here. I'm logged in. So if it's your first time, this is where you will land. Create a workspace for yourself. Creating a workspace is very easy. Just click on create workspace, and then attach to your workspace, create a database. Creating a database is also kind of very easy. I have already created my database, that is LangChain DB. That is my database, and Power Appy workspace is my workspace. So once you create this, the next thing is to go to Data Studio. So once you go to Data Studio, this is where you can create a new notebook, right? Give it a name, make it personal, share, and then create one. So I have the link ready. Let me go to the my notebook code. So my notebook code is already here. So once you create your new notebook, you can just go paste this whole thing. I'm going to share this. Um, Paste this, start working on your notebook. So here is a simple case study, right? RAG using LangChain and single store. So before anything, make sure you select your workspace that you created and the attached database where you want to store your embeddings. Right. So first things first, install libraries and dependencies. I mean, installing LangChain, single store database, and then import the libraries. I'm importing some libraries, and then load your custom document. So this is the document that I'm loading. It is, let me see what is this. Let's go and just look at it, have a look at it. This is some global monitoring report on non-bank financial intermediation 2024. So it's a big report, as you can see. So we are using that publicly available PDF file. We're going to load that using LangChain community document loaders, right? And then we'll split the document into chunks. Now we loaded the document. Let's split it into chunks using LangChain text splitter, recursive character text splitter. And then, as you can see, you have 76 documents in your data. There are 86 characters in your document, and you have 121 pages, right? And let's use OpenAI to generate embeddings for the document chunks. Now we created doc chunks. Let's create embeddings for these chunks. Like I provided my OpenAI key, OpenAI API key, and let's store our document embeddings into single store database. So this is the whole code, and then I'm creating a table inside my database, FSB table, and that's where I'm going to store my vector embeddings. Right, so we'll load that, and this is how. Let us check the text chunks and associated embeddings stored inside our database. Right, so if you see that this is a simple sample how it is stored, right? How the data is stored. Basically, I'm going to show you how it is stored. So let's ask a query against our custom data that the PDF file we loaded. We're just using similarity search. So what was the growth rate of the NBFI sector in 2023? So this answer response is already there in the PDF file. We just ask the question, and here you can see the answer, the responses, just using similarity search. So this is very big. We don't want this. We might want some augmented response using proper RAG approach. So this is the augmented response for the user query. We are using model GPT-4 model, and we are also using from LangChain the role, the system prompt template. And this is how the response is proper, accurate, contextually relevant response using the RAG approach. The growth rate of the non-bank financial intermediation in BFI sector in 2023 was 8.5%. And some other information also it is provided. But this is the type of response we expected, and we got it using augmented response like the RAG approach. And let's now test the knowledge when knowledge base is not provided, right? When the custom document is not provided, and if we just ask a query like this one, like what was the growth rate of NBFI sector in 2023? If you ask that, right, I asked it here, and it will say like the growth rate of NBFI sector in 2023 cannot be accurately predicted, as it depends on various factors and blah blah blah. So since we did not provide any custom document through our vector store, it is very hard for the system to predict the proper contextually relevant answer. So that is where RAG comes very handy, and that's how RAG should be used. And this is again another query I used similarly. I mean, yeah, unfortunately, it is not possible to accurately predict. So when the knowledge base is not provided, right? But with knowledge base, it will say is that the countries that saw the highest increase in the non-bank financial intermediate sector in 2022 were Brazil, Cayman Islands, Japan, Mexico, and United States. So hope you understood how we can basically build robust RAG applications using LangChain. So let's go back. Now let me show you how how the vector, the data has been stored. Let's go to deployments, database, the database that we use, LangChain DB. And as you can see, FSB table was a table inside our database. And this is the sample data, right, in a vector format. This is the vector format that you see, right? So whole document that we loaded is stored in the form of vector data. Since we used LangChain, we chunked it, we stored it as a vector data. We converted the whole chunk into vector embeddings using OpenAI. So that's about the LangChain using RAG using LangChain and single store. And let's go to RAG with LangChain and single store. With sorry, LlamaIndex and single store. So this is LlamaIndex. This is where LlamaIndex helps you with like to load the document text splitters, embedding generation, and text construction. And we store all this data into our single store database. And when a user query comes in, it processes and goes through the uh, single store database to fetch the relevant answer using vector search methodology. And then finally, it goes through the LLM model to formulate the final answer back to the user. So we're going to see that also. This is the next hands-on. So create a free account on single store. You can use this, or you can use this link, mm, or use the screenshot, take a screenshot and go to single, or you can directly go to singlestore.com. Like previously, how we did, create a workspace and a database, create a new notebook. Make sure to select workspace and database on your notebook, and then let's go to the directly to the code part. Okay, so RAG with LlamaIndex, we will install the required libraries, LlamaIndex, and we'll also install single store, and we'll import the required libraries, and we'll set API keys required. We're gonna import, set opening API key, single store DB URL, and we will download and save the PDF. Here also, I'm using some publicly available PDF file. This is the PDF file. We'll save it. We'll index it and initialize the vector store, and then mention the embedding model and the required settings. So this is the embedding model I'm going to use. Model is GPT-4. We're going to set some temperature, load and process the document. We are going to load and process the document. Number of documents loaded 178. First document content preview 2023 world economic situation. So the PDF that we are loading is all about world economic situation and prospects, something based on that, and create and persist the index using llama index, and then function to query the index. So these are the example queries. What are the main economic challenges discussed in the report? What are the key recommendations for policymakers? And as you can see, these are the proper contextually relevant responses back to the user. Right. So this is about RAG using Llama Index. So I also have another code that I want to show. So RAG with Llama Index, we're gonna load some dependencies and libraries. We're gonna import um, some libraries, and then we're gonna mention OpenAI API key, Google API key, and then this is here I have a CSV file. I'm gonna use the CSV file with some title and related content just to show you how Llama Index works with the RAG setup. I'm going to load that CSV file. I loaded that CSV file, and um, this is what all the content that is present in my CSV file, the title and some description. And if I ask a query, let me ask a query, right? Using the Gemini model, we are using Gemini model here. Before we used OpenAI model, Gemini 1.5 Flash, temperature and max tokens. So if you ask a query like what is single store's npm package need? So it is present. The answer is actually present in the CSV file. So but it is present in a huge chunk in a very paragraph format. But as you can see, we get a proper relevant answer back. Right? The npm package name is single store client, so that is the name. So that's how you can basically use llama index to create powerful RAG applications. So that's about my talk. But also, many people keep asking me like, "Hey, Pawan, we have LangChain and LlamaIndex. When to use what?" Right? So it all depends on what you want to achieve with your RAG applications. You need to define your requirements with RAG, and then the primary. If the need is, if you have a complex orchestration, right? You want to do advanced. You want to do advanced workloads, workflows, and chaining, agent creation, and memory management. Then use LangChain. And if your focus is more on data indexing, vector search, doing proper retrieval, efficient data ingestion and semantic retrieval, then use Llama Index. And also, some people suggest using both. right? You can also combine both and see the results if you have mixed requirements, right, for your RAG project. But you can also use both. I have not seen many people using both, but you can use both for the first half, like to load, index your data. You can use LlamaIndex, and the second part, like to create prompt templates to query and to do all those things. To get relevant answers, you can basically use LangChain. So here is a simple. I have a code also, notebook code that I just just tested using both LangChain and LlamaIndex. Um, so in this example, we use LlamaIndex for indexing and then use LangChain LLM chain to further process the retrieved context into a final answer. So first off, you are using LlamaIndex, and then the second part, you are using basically the LangChain's chaining part to basically build your whole application, RAG application. So install LangChain and LlamaIndex. As you can see, we are installing both. We're gonna use a opening API key, load our custom document, store it, and create a query engine, right? And then using LLM chain from LangChain to further process the retrieved context into a final answer. So as you can see, right, we are using LangChain's chain format that chaining together all the modules and LLMs, prompts and LLMs. So as you can see, final answer for this query based on the document, what are the main risk management strategies mentioned? The key topics discussed in this document, blah, 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 blah. Yeah. So this way you can also use both, but I don't know how much, I'm not that sure of using both because it adds more complexity. So I always prefer using one over the other. So it all depends on your RAG requirements, the application requirements. And yeah, thanks. Let's follow each other on LinkedIn. I'm very active on LinkedIn. Um, One of the top voices on LinkedIn. I keep sharing a lot of AI, Gen AI related content on LinkedIn. And thanks for attending my talk. Thank you.